Now that we've configured all our analysis settings, it's time to run the structural analysis and review the results. In this video, I'll show you how to use the Analysis plus Design command in ideCAD, and then inspect your model using the structural inspection tools. From deformation and load diagrams to slab reinforcements and foundation pressures, everything you need to understand your structure's behavior is built right into the platform. Let's get started by running the analysis. To perform analysis and design in ideCAD, use the Analysis plus Design command. This operation performs the vertical load analysis, modal analysis, and the design of both concrete and steel elements, including foundation and slab elements, based on your analysis settings. Both horizontal and vertical load combinations are automatically generated. Using these combinations, the program carries out the analysis and calculates the structural design results for all elements. To start, click the Analysis plus Design icon from the ribbon menu, or simply press the F9 key on your keyboard. A dialog box will appear, asking, "Do you want to perform analysis?" Click OK to proceed. Once the process begins, you'll see the analysis status window. This window displays each step of the analysis and design process, along with the time it takes to complete each operation. This gives you a clear overview of what is happening behind the scenes during structural analysis in ideCAD. Once the analysis is complete, we can examine the model. To switch to the analysis model, click the Analysis Model icon under the Structural Inspection tab in the ribbon menu. To return from the solid view to the Solid Analysis Model view, click the Analysis Model icon. In the Perspective view, you can also switch to the Analysis Model by right-clicking and selecting the Structural Visualization option or Analysis Model from the context menu. In this case, the visualization window will also open on the screen. The appearance of the analysis model, such as nodes, element names, and local axes, can be controlled from the Visualization dialog under the Analysis Model tab. Show nodes and links. When this option is enabled, all nodes created at the joints between structural elements will be shown as red points in the model. Show node numbers. If this option is also enabled, each node's identification number is displayed. This makes it easy to reference or locate specific joints. Show supports. Turning this on displays the support conditions in your structural model. You'll clearly see where supports are defined throughout the system. Show element names. When active, this option displays the name of each element, such as beams and columns, directly above them. For example, you might see a label like K10 for a beam or S12 for a column. Show local axes of linear elements. This setting reveals the local axis orientation for each linear element, such as beams or columns. It's helpful for understanding how internal forces are calculated based on the element's local coordinate system. Show local axes of shell elements. Similarly, this setting will show the local axes for shell elements, such as slabs or walls, directly on the model. Show hinges and end releases. This option highlights hinges or released connections defined on structural elements. These details are essential for understanding rotational behavior and degrees of freedom in the frame. Extrude elements. When enabled, elements are shown as solid volumes instead of simple line representations. This gives a clearer visual of the structure in 3D. Show diaphragms. Finally, if this option is checked, all defined diaphragms in the structure are displayed, organized by story. This is useful after running the analysis, especially when reviewing diaphragm behavior. Deformations. Deformation results show the displaced shape of the structure under a selected load case. You can open the Deformation tab by selecting Modal or 1.4G plus 1.6Q from the Structural Inspection tab in the ribbon menu. You can examine the deformations by selecting the desired combination or case status from the list. In the Deformation tab, Extrude Elements shows solid members instead of line representations. Use Hotspot Scale, color scale from red to yellow for deformation intensity. Manual Scale Factor, you can set a specific deformation scale. Displacement component to view, choose total, X, Y, or Z displacement. Loads. The Loads tab allows you to visualize different load types acting on the model. Access it from the Structural Inspection tab or via the Visualization window. Settings like Manual Scale Factor, Units, and Filters help customize how loads are displayed. You can select from various types of loads, including own load, user-defined loads, wall loads, live loads, slab loads, auto-lateral loads, as well as snow, purlin, sheeting, crane, and soil loads. Choose the correct combination to see relevant loads. Frame results of elements. Normal force, shear force, and moment values in rod elements can be viewed based on their local axes. Choose a component, like axial, shear, or moment, and select a load case to view. Shear wall results. Shear walls can be examined for axial force, shear, and moment using the same approach as for frame elements. Purlins and strip foundations results for strip foundations and purlins can be viewed the same way. Use the analysis model under the concrete tab and examine force and moment diagrams in local directions. Shell results. To view results of shell elements like slabs, rafts, domes, stairs, and pools, go to the Shell Elements section in the Analysis and Design Display tab. You can view cross-section effects such as M11, M22, and M12 moment diagrams based on shell element local axes, V13 and V23 shear forces, and F11, F22, and F12 axial forces, while rebar area diagrams can be visualized as required reinforcement areas on the S1 and S2 bottom, top, and visible sides, for better understanding. The base pressure diagram displays the pressure distribution on raft foundations to evaluate how loads are transferred to the soil. While the soil stress check diagram in ideCAD visualizes the comparison between base pressure and the allowable soil bearing capacity, QT, using a color scale, where red indicates the highest stress levels, not necessarily a failure, and the full gradient represents varying pressure intensities to assist in the assessment of foundation behavior. Now we will change the view on the perspective screen via the View tab and return to the Concrete Design tab. Concrete design. You can view design input data such as material and section types, element lengths, stiffness reductions, wall loads, slab thicknesses and dead loads, beam live loads, and the modulus of subgrade reaction from the Concrete Design input section under the Structural Inspection tab. Concrete Design output section provides visualization of results like longitudinal rebar percentages, shear and axial failures, all failures, rebar deficiencies, deflection and crack failures, punching checks, capacity ratios, column beam joint failures, and overall performance damage zones, interpreted using a color scale, where red typically indicates the most critical or insufficient conditions. When steel design is done, you can also view inputs and outputs from the Steel Design tab. We can examine our model in this way either from the Structure Inspection tab or through the visualization window we opened. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.